Electric current. Have you ever seen a lightning strike? Well, lightning is a large version of when your hand touches the doorknob and gets that spark. It's a large static discharge, which is a transfer of charge between two objects because of the buildup of static electricity. As air masses move and swirl in a thundercloud, areas of positive and negative charge build up. Eventually, enough charge builds up to cause a static discharge between the cloud and the ground. As the electric charges move from the air, they collide with atoms and molecules, and these collisions cause the atoms and molecules in air to emit light. You see this light as a spark that we call lightning. And when this spark jumps between the cloud and the ground, the net movement of electric charges in a single direction is called an electric current. In a metal wire or any material, electrons that are in constant motion in all directions. As a result, there is no net movement of electrons in one direction. However, when electric current flows through a wire, electrons continue their random movement, but they also start drift in the direction that the current is flowing. The movement of an electron in an electric current is similar to dropping a ball in a moving stream. Even though the ball changes direction when it strikes a rock or a branch, the net motion of the ball is with the current of the stream. The motion of the ball is caused by the current and this force of gravity. So when a current flows, the net movement of electric charges is caused by an electric force acting on the charges. And electricity will flow from a higher voltage to a lower voltage. A voltage difference is related to the force that causes electric charges to flow. And voltage difference is measured in volts. Think of riding a roller coaster at an amusement park. You would keep going around and around in a loop, which would be super fun, by the way. However, those dang employees always seem to hit that brake and stop the roller coaster and make you get off to let the next people get on. Well, that roller coaster operator is acting like a switch on a circuit where you and the roller coaster act like the electric current. A closed path that an electric current follows is a circuit. And if that circuit is broken by, say, removing a battery or a light bulb, turning off the switch, or even removing wires, then current will not flow. We said before that there needs to be a voltage difference, an area of high voltage to low voltage, to keep an electric current continually flowing in a circuit. One item we use to provide that voltage difference is batteries. Current will flow as long as there is a closed path that connects one battery terminal to the other battery terminal, which means the plus end and the minus end that we know of on batteries. Now, you are probably most familiar with dry cell batteries. This is a cell which consists of two electrodes surrounded by a material called an electrolyte. Looking at this AA battery, one electrode is a carbon rod that sits at the center of the battery, and the other electrode is the zinc container. Now the electrolyte, which you can't really see, but it's in there, you might see it sometimes, chemicals leak from it if the battery is left in a toy too long, contains a moist paste containing several chemicals. This electrolyte, this moist paste, surrounds the carbon rod in the center. This is called a dry cell battery because the electrolyte is not a liquid solution like what you would find in a car battery or a wet cell. Wet cell batteries contain two connected plates made of different metals or metallic compounds in a solution that can conduct electricity. In wet cell batteries, chemical reactions transfer electrons from lead plates to lead dioxide plates. Now look at this picture. What is making this light bulb glow? If you were to look at a light bulb, there's a thin wire in the middle of it called a filament. Part of a circuit through the bulb makes its way through this filament. As the electrons flow through the filament, they bump into the metal atoms that make up the filament. And in these collisions, some of the electrical energy of the electrons is converted into thermal energy. And eventually that metal filament becomes so hot from that thermal energy, it begins to glow, producing radiant energy that we see as light in a dark room. Now, when that electric current moved through that filament resisted that flow of electrons. and that resistance caused electric currents to lose energy. Resistance is the tendency for a material to oppose the flow of electrons, which changes electroenergy into thermal energy and light. Now, as temperature increases in a material, electric resistance usually increases as well. The resistance of an object, such as a wire, also depends on the length and the diameter of a wire. The resistance of a wire, or any conductor for that matter, increases as the wire becomes longer, and the resistance will also increase as the wire becomes thinner. All materials have some electrical resistance. Of course, electric conductors have much less resistance than insulators, and when measuring resistance, we measure it in ohms. The relationship between voltage difference, current, and resistance in a circuit is known as Ohm's law. According to Ohm's law, the current in a circuit equals the voltage difference divided by resistance. Ohm's law can be written as the following equation. Current is voltage difference divided by resistance. Okay, it's time to show what you know.